much as I am old. So I'm 16.
Oh, gotcha.
You know?
Hey girls, Chloe and Avalee, we're gonna like do a little bit into 4-4, not too much. Here's homework problems for this, but we'll just go through a little bit of this. When you guys are using your unit circle, which one is X and which one is Y?
Sine is Y, cosine is X.
Sine is Y, cosine is X. I just remember it goes the opposite way. Like you think sine, cosine, tangent, like sine comes first, but it does not. Cosine is the X coordinate, sine is the Y coordinate. Okay, so I had you guys, did you guys write these on your unit circle? I don't remember. Did you write like the plus plus, the minus plus, whatever? Okay, so what that means is that like in the first quadrant, you are going to the right and you're going up. You're going positive and positive, right? So the cosine is positive, the sine is positive, yeah? In the second quadrant, you're going to the left, which is minus, and you're going positive for the y. So negative for cosine, positive for sine, right? And then all the way around. So this would be minus, minus. You're going to the left and down. Here you're going to the right and down, so plus, minus. So cosine's positive, sine is negative. We know all that stuff. That is the way that it works. Got it?
Got it.
Okay. All right. Example 1. Let P, -2, -5, be a point on the terminal side of an angle. Let's just talk about that for a second. Let that point be a point on the terminal side. What does a terminal side mean?
Well, where it ends.
Where it stops, where it terminates, right? So -2, -5 is in the which quadrant?
Third.
Third. -1, 2, -1, 2, 3, 4, 5. Okay, so this dot is on the side of a terminating angle, which means my angle starts here and it ends right there, right? So like I have that thing going on, right? And what I'm going to do is I'm going to make him into an angle, okay? So, or a triangle, I guess, per se. Okay, which way do you draw your triangle? Up. I'm going to go straight up. So I'm going to draw my triangle like this. So and where's angle theta live? Right there. Okay? It says, drawn in standard position, find the value of the 6 trig functions. Okay, so I'm just going to start with sine of theta, cosine of theta, tangent of theta. This is, what's opposite of sine?
Secant.
Cosecant of theta, secant of theta, cotangent of theta. Okay, there is all of that. Very nice. Okay, now, I got to label my sides. So,
-2 is this one.
-2 is this one.
-5
-5
is this one.
is this one.
Then we have to figure out the
We have to find the hypotenuse by doing the Pythagorean theorem. So -2 squared plus -5 squared equals c squared. Now, if you want to just forget about the negatives, that would be a great idea. -2 squared is going to be +4, right? So if you want to just like leave off the negative and not even think about the negatives, that's totally fine. 4 plus 25 equals c squared, and that is the square root of... What are you talking about? 29. The square root of 29. Now, does 29 break down? Does 29 break down? How do you know?
prime.
Because it's prime. Yeah. It's prime. So I'm going to leave this as the square root of 29. Now, is he positive or negative, square root of 29?
Positive.
Hypotenuse is always positive. Okay, so we have that. Now, here's the problem. If we end up with 29 on the bottom of our fraction, we're going to have to rationalize, right? Okay, so sine, let's label our sides here. We have angle theta lives here. -5 is which side? Opposite. We know hypotenuse is here, and then this guy would be the adjacent side. So sine is OH, right? Opposite hypotenuse. -5 over the square root of 29. If you rationalize, that is...
-5 square root of 29 over 29.
Beautiful. Got it. Okay,
Cosecant
good.
would be
Cosecant, take and flip this guy.
Square root of 29 over 5.
Square root of 29 over -5. I'm going to put the negative out front. Negative square root of 29 over 5. Good? Cosine is A over H. So kind of the same thing. We got -2 over the square root of 29. Or -2 square root of 29 over 29.
Yeah.
Yep. If you flip the first one.
Negative square root of 29.
Awesome. There you go. Okay. And tangent is OA. No rationalizing there. That's nice. Opposite is -5. Adjacent is -2. So we got -5 over -2.
-2, no, positive.
Just leave it as 5 over 2. But we can cancel the negatives. Okay. Cotangent will be 2 over 5. Awesome. Yep. Okay. Good? Happy with that? So you're just plotting points, making a triangle, all of the things. I want to say we've done that already before. Maybe. Okay. Next thing, and this is like probably the last thing that we'll do, is something called a reference angle. A reference angle. So here's the deal. In the first quadrant, let's say you have something like 65 degrees. 65 degrees lives in the first quadrant. 65 degrees has a 65 degree reference angle. Because he's in the first quadrant, he is easy. Okay? All right, here's the deal. Let's say we have something in the second quadrant. Let's say we have like 110 degrees, let's say. Okay? Your reference angle, I'm going to write out reference angle, circle reference angle, is the bow tie angle. Your reference angle is your bow tie angle. Okay, so if I have something that is 110 degrees here, do you know what I'm talking about with my bow tie? What are you talking about? I know, it's squeaking. It's got like tape that's rubbing. This is my bow tie angle, right? So if this is 110 degrees, I want to know what this bow tie angle is right here. What's that angle going to be? 70. That is your reference angle. So 110 degrees is equal to a 70 degree reference angle. In other words, they have a little cheat sheet here for you that says that if you're in the second quadrant, you just subtract that number from 180, right? Because that would be like the rest of the way. Okay, let's do another example of that. So let's say I have, give me another angle that's in the second quadrant.
111.
You silly boy.
134.
Go something easy. Let's go like 150. I don't know. 150 degrees. What would be his reference angle? 30. It would be this bow tie angle right here. Got it? Okay, third quadrant. Third quadrant. Let's do an example of something that's in the third quadrant. 180 is right there, right? So let's say like
181.
let's say like 200 degrees. Okay? 200 degrees. Okay? Your bow tie angle is this angle right here. This one. What's the amount of that bow tie angle if we're talking a 200 degree angle? 20. So what'd you do?
That minus.
You took the angle and you subtracted 180 that time, right? Okay? Let's go instead here. Whoa. Let's go instead. Let's do another example. Let's say we have 260 degrees. What is happening? 260. 3/4 of a turn would be 270, right? So he's slightly less than that, right? But the bow tie angle would be like this amount right here. What's this angle right here? 80 degrees, okay? Because 180 would be here. Oh my gosh, 260 minus 180 is the bow tie angle, and that is 80 degrees. Is this making sense-ish? Okay, 360. Or like in the fourth quadrant, let's say you have an angle that is, gosh dang it. Blah. Will you quit doing that? Why is he doing that? Un momento, por favor. Okay, I don't know what he's doing. Okay, all right. Okay, let's say we have a 300 degree angle. So from here to here is 300 degrees. And here is my guy. Your bow tie angle will be this guy. And what's this measure right here? 60 degrees. So it's like what the rest of the way would be. So you're taking 360 minus whatever your angle is. Okay, let's do another one. Let's say we have, let's go 280 degrees, which is a little bit past this, right? If this is 280, what would my bow tie angle be? What would the rest of the way be? 80. You got it. You see how that works? Yes? So the reference angle is your bow tie angle. It's like what your acute angle would be for that triangle. Got it? All right, find the reference angle. What quadrant is 315 in? You don't have to graph these, but it like kind of helps me the first couple times.
15 would be in the fourth.
Fourth quadrant, right? 315, okay? So if 315 is here, what would this little angle right here be? 45 degrees is your reference angle. That's the answer. Got it? Not too bad. We can do these. Okay, negative 195. I do not like to graph negative 195. Negative 195. So you could, I guess you could graph him. Negative means you're going in this direction. That's negative 90 degrees. I wish you wouldn't do that. This would be negative 180 degrees, right? So negative 195 degrees would be slightly there, right? So this little angle, 15 degrees, right? Because 180 would be that. And 180 plus 15 is 195. So 15 degrees is his reference angle. Now, if you want to, and you don't like dealing with negative degrees, what could you do instead? To make him a positive degree.
Take the coat.
Yeah, so I'm gonna add 360 to that. 195 plus 360 is gonna be like 165 degrees. 165 would be this much, 165, but he would still have a reference angle of 15. So same thing. Good?
Yep.
C, what the heck is that? Whoa,
Radians.
that is a radian. Ugh. Okay, all right, let's think in terms of radians. That's a radian as a decimal. 0 radians lives here. Pi over 2 radians lives here. Do you know what pi over 2 is as a decimal? Take pi divided by 2. Take pi and divide by 2. It's like 1.57, I think.
1.57.
Okay, that's 1.57 radians. How many radians is it from here all the way to here? Pi or
3.1.
3.14 is a decimal, right? Okay,
It's gonna be in the third.
it's probably going to be in the third quadrant, right? Okay, how many radians is 3 pi over 2? Whatever those two added together are, like 4.71. If you take 3 pi over 2 and make it as a decimal. 4.71, I think. Something like that. What would be all the way around? 6.28. Okay, so if we're talking decimal radians, we're talking in the third quadrant. That's what 3.5 is. Okay, how do I figure out what this angle is right here? My bow tie angle.
I'm not sure on that one.
This one's a little bit harder to think about. How many radians is it from like here to here?
3.5 minus
3.14 is that purple, right? What's the rest of the way? Whatever 3.5 minus 3.14 is.
3.36.
So 0.36 radians. 0.36 is the reference angle in radians. Does that make sense? You're just figuring out what he is. Yeah, I don't like those. Okay, this one, 25 pi over 4.
Code term.
Bleh. 25 pi over 4 is huge, right? Because 25 divided by 4 is 6.25. That's way more. That's like way more than 3 full circles around, okay? So to reduce him down, let's subtract 2 pi, which is like subtracting 8 pi over 4, right? Okay, 25 pi over 4 minus 8 pi over 4 is 17 pi over 4. Let's
Taking away twice.
subtract another 8 pi over 4, which is 9 pi over 4. Let's subtract another 8 pi over 4, which is
1 pi.
1 pi over 4. Do you know where pi over 4 lives? In the first quadrant right here. That's pi over 4. What's his reference angle? Yeah. Any angles in the first quadrant have their same own reference angle, right? So pi over 4 is his reference angle. I didn't circle the correct answer. Yes, I did. Yes, I did. Okay, happy with that? Not too bad? Yep. Okay, well, we'll stop there. That's fine.
I want to go to the bathroom.
You may. All right, goodbye, girls.